Welcome to the Deep Dive. You sent over a whole stack of fresh AI research, all polls from the last 24 hours on rx5e.org.
Really hot off the press stuff.
Yeah, consider us your guides through this jungle of papers.
That's right.
We're going to cut through the jargon, figure out what's really exciting, and try to give you a sense of what's buzzing in the AI world right now.
Everything from the theoretical breakthroughs to the really cool practical applications.
Ready to dive in?
Absolutely. Let's go.
All right, so one thing that really jumped out at me from this set of papers
Yeah.
was denoising.
It seems like everyone this week is talking about diffusion models.
Yeah, it definitely caught my eye too. What is it about this concept that has the AI community so captivated right now?
So imagine you take a photo
Okay.
and you just add noise to it until it's just pure static.
Uh-huh.
That's what these diffusion models do, but then they train a network to reverse that process and learn to denoise it step by step.
So it's like you're taking a super blurry photo and having AI magically sharpen it.
Yeah, it's more than sharpening, though.
Okay.
It's actually generating new data from noise.
Wow.
So think of it as like sculpting a statue,
Okay.
but you're sculpting it out of static.
That's a really cool analogy.
Yeah.
Now, one of the papers that I thought was really interesting was this lit paper.
Lit-T delving into a simplified linear diffusion transformer for image generation.
Yeah. Yeah, and they're using this method for image generation, right?
Exactly. They've developed this really cool new type of diffusion model called a linear diffusion transformer, and it's incredibly efficient.
Interesting.
It can actually generate these high-quality images offline on just a laptop.
Wow, that is pretty impressive.
Yeah.
What about this paper on AMMDiff, Adaptive Multimodality Diffusion Network for Missing Modality Imputation?
Oh, yeah, that's a great one.
It sounds like diffusion models are making a splash in medical imaging, too.
Absolutely. So this paper looks at dealing with missing data in medical scans.
Okay.
So imagine a patient who can't get a certain type of MRI because of a health condition. This model can actually step in and generate the missing information from that scan.
So almost like filling in the gaps in a puzzle, but with really, really potentially life-saving implications.
Precisely. Yeah, there was another really cool study.
Yeah.
Treatment-aware diffusion probabilistic model for longitudinal MRI generation and diffuse glioma growth prediction. And this paper uses diffusion models to actually predict tumor growth from MRI scans.
Wow. So this could change the game in terms of personalized treatment plans.
Yeah, absolutely.
It's amazing to me how you can apply this denoising both to creating the images and then analyzing them.
Yeah, it's super versatile.
It doesn't stop there, though.
No, it's not.
Denoising is popping up in some pretty unexpected places.
Yeah, you see it all over the place.
What are some of the more surprising applications that you've come across?
We'll take the score-based diffusion models in function space paper. Instead of working on pixels, this is using diffusion models on functions.
Functions. Okay, break that down for me a little bit more.
So instead of like creating images, these models can generate complex equations or even 3D models.
So it's almost like AI is learning to work in like an abstract mathematical space.
Yeah, it really highlights how this technique is going beyond just mimicking visual data
Wow.
and getting into like the realms of pure mathematics. And there's also a lot of really cool work being done on the theoretical foundations of diffusion models.
Yeah, the ODT convergence theory for diffusion probabilistic models under minimal assumptions paper caught my eye.
That's a good one.
It seemed really technical.
It is. It's very technical.
What's the main takeaway for someone like me who's not super deep in the math?
So it basically analyzes how quickly and under what conditions these models converge to the true data distribution. So it's basically trying to understand the mathematical nuts and bolts of why they work so well.
So it's like providing a deeper understanding of the magic behind these models.
Exactly. And this kind of theoretical research is really essential for building even more robust and reliable diffusion models in the future.
So it's clear that denoising is a hot topic, but the world of AI is never content to just stick with one thing.
Oh, no.
What other trends are you seeing in this batch of research?
Well, two big things that kind of go hand in hand are efficiency and scalability. You see a lot of researchers really focused on how to reduce computational demands and make AI more accessible without sacrificing performance.
Yeah, the journey matters. Average parameter count over pre-training unifies sparse and dense scaling laws really caught my attention.
Oh, that's a great one.
Seems like it's tackling the issue of massive language models head on.
Yeah, so they're exploring this really interesting technique called sparse pre-training.
Okay.
And basically think of it as like streamlining the model's architecture from the very beginning. So by training with fewer parameters, they can significantly reduce the model size
Okay.
and the computational needs without compromising the performance.
So essentially, they're making these really powerful language models leaner and meaner.
Exactly.
Yeah. That's really cool because then that potentially opens it up to more people,
Right, exactly.
to researchers and developers who maybe don't have access to these massive computing resources.
It has the potential to really democratize AI development.
Yeah, that's really exciting.
Yeah.
Another efficiency booster that I saw was this CrossD-Conv, cross-dimensional transferable knowledge base via Fourier shifting operation paper.
Oh, yeah, that one's super cool.
And this one's dealing with cross-dimensional transfer learning, right?
That's right. So this is all about training a model on one type of data and then applying it to a completely different type of data.
Okay.
So for example, imagine training a model on 2D images
Okay.
and then using that knowledge to analyze 3D medical scans.
So it's almost like taking knowledge from one field and being able to apply it in a different field.
Exactly. And this is really powerful, especially in areas where 3D data is hard to come by.
Right, like in medical imaging or something like that.
Exactly. It could really speed up research and development.
This is incredible. It's like AI is learning to connect the dots between totally different dimensions.
Yeah, it's really cool.
What other real-world applications stood out to you in this batch of papers?
There were quite a few, but one that was really interesting was this CERET-X toward building a foundation model for SAR target recognition paper. And this introduces a new model for identifying targets in SAR imagery.
Okay, so remind me what SAR stands for again.
It's synthetic aperture radar data.
Right, okay. And that type of radar is used for?
So it's used for remote sensing and imaging.
Mm-hmm.
So, applications in defense and intelligence, but also in environmental monitoring. So things like tracking deforestation
Oh, interesting.
or identifying illegal fishing vessels.
Wow, so AI is becoming this really powerful tool for not just understanding our planet, but managing it too.
Absolutely.
Any other real-world applications that really piqued your interest?
Yeah, this one was really cool. It's called Optimal Sequential Decision-Making in Geosteering, a reinforcement learning approach. And this looks at using deep reinforcement learning for something called geosteering in the energy industry.
Geosteering, what's that again?
It's basically the technique used to guide drilling operations.
Oh, right.
So this paper proposes using AI to actually optimize those drilling paths in real time.
Wow, so instead of relying solely on human judgment, we can have AI helping to make those decisions,
Exactly.
potentially making them more efficient and maybe even less impactful on the environment.
Right. It's a great example of how AI research is actually translating into solutions for real-world problems.
This is all incredibly exciting, and we've only just begun our deep dive.
We've got a lot more to explore.
But you stay tuned, listeners,
Right.
because things are about to get really, really interesting.
So, we've been talking a lot about the technical advancements in AI.
Yeah.
But AI isn't just about building better machines. It's also a powerful tool for understanding ourselves.
That's a really interesting point. And this next paper that we're going to talk about kind of delves into that idea a little bit.
Right.
Human-like conceptual representations emerge from language prediction.
Catchy title.
It is catchy. It sounds fascinating. What's going on in this one?
So these researchers wanted to see if large language models,
Okay.
or LLMs, can actually develop conceptual representations.
So can AI organize and understand concepts the way that we do?
That's the big question, right?
Yeah.
So to do this, they use this really interesting task called a modified reverse dictionary task.
Modified reverse dictionary.
So imagine I give you a definition and you have to guess the word.
Oh, okay. So it's like a verbal game of charades almost.
Exactly.
And they did this with LLMs.
Yeah, they gave these LLMs these definitions
Oh.
and had them try to come up with the word, and the results are actually pretty remarkable.
Oh, really?
Yeah.
What did they find?
These systems were able to accurately infer those concepts and organize them in a way that was really consistent with human judgments.
So it's suggesting that they're not just processing words, but they're actually starting to develop some level of like conceptual understanding.
Right. They're going beyond just the surface level.
That's incredible.
Yeah. And they even took it a step further. They
Okay.
actually compared the representations that the LLMs learned
Mm-hmm.
to human brain imaging data.
Oh, wow.
And they found that the way these LLMs organized these concepts actually mapped onto patterns of neural activity in the human brain.
It's like these systems are starting to think a little bit like us.
Yeah, in a way, it's a really cool demonstration of how AI research can actually shed light on the inner workings of our own minds.
This has been such a whirlwind tour of all this cutting-edge research.
Yeah.
I have to ask, is it ever overwhelming for you to try to keep up with all of the latest developments in AI?
Oh, yeah. The volume of research that comes out is just staggering.
Yeah.
Really is like drinking from a fire hose, but that's also kind of what makes this field so exhilarating. There's this constant sense of discovery, this feeling of being on the cusp of something truly transformative.
It's really a privilege to kind of witness it unfold in real time.
Yeah.
So we've talked about some of the really groundbreaking research, but let's zoom out a little bit and talk about the bigger picture.
Sure.
What kind of impact is AI research having on the world at large?
I mean, AI is having a huge impact across so many different industries, and it's only going to continue to grow. And one of the biggest areas where we're seeing its influence is in personalization.
Oh, interesting.
So in healthcare, education, and beyond, AI is allowing us to move away from these one-size-fits-all solutions.
Right.
And actually create experiences that are tailored to the individual.
Yeah, that level of customization is incredibly powerful.
Absolutely. And it has the potential to revolutionize so many aspects of our lives.
What about the impact of automation on the workforce? That's something that a lot of people are thinking about these days.
Yeah, it's a big question. And AI is definitely automating tasks in a variety of industries. Right.
And as these systems become more sophisticated, they're going to be able to handle even more complex tasks, which will free up humans to focus on more creative and strategic work.
Yeah.
You know, throughout history, technological advancements have always led to shifts in the job market.
That's true.
New jobs emerge and old jobs disappear.
Yeah, it's the nature of progress.
Exactly.
But I think it does raise an important point, though, which is that we need to adapt.
We do.
Our education systems,
Yes.
our training programs.
Absolutely.
To prepare the workforce for the jobs of the future.
Yeah, we need to make sure that people have the skills they need to thrive in this world that's increasingly powered by AI.
To really harness its potential.
Exactly.
So this deep dive has taken us through a lot.
Yeah, it has.
From these really mind-boggling denoising techniques to the idea that AI can form these conceptual representations to those broader societal implications.
Right. It's a lot to take in.
It is a lot to take in.
One of the big takeaways for me, though,
is just the sheer pace of innovation in this field.
Yeah, it's really remarkable.
We're witnessing these breakthroughs happening in real time.
And it's not just about building smarter machines.
Well, it's not.
It's about using AI as a lens to understand ourselves and the world around us better.
Yeah, I think we're at this really pivotal moment in the evolution of AI. And it's up to all of us to shape its future in a way that benefits humanity as a whole.
This has been such an enlightening conversation.
It really has.
Our journey continues, though.
Oh, it does.
We have one final kind of fascinating area of AI research to explore.
I'm intrigued.
One that's often overlooked.
Okay.
It holds immense potential.
I'm ready. Tell me more.
Let's talk about the unsung hero of AI. Efficiency. Efficiency, it's not the most glamorous topic.
It's not the flashiest.
But I feel like it's going to be one of the most crucial aspects of AI.
It's going to be huge.
As it continues to kind of infiltrate every area of our lives.
Absolutely.
And evolve.
Yeah.
So what are some of the ways that AI researchers are tackling this challenge of making AI more efficient?
Well, it's about more than just making models faster or smaller.
Okay.
It's really about getting AI to do more with less.
Okay.
Less data, less energy, less time.
So working smarter, not harder.
Exactly. And this batch of research actually has some really clever approaches to achieving that.
That's cool. What are some that stand out to you?
Well, this one called On Accelerating Deep Neural Network Mutation Analysis by Neuron and Mutant Clustering. It's a mouthful.
It is the mouthful.
But it's a cool paper.
Okay, break it down for me.
Okay, so they present a new method called DeepMAC
Okay.
for speeding up mutation testing in deep neural networks, or DNNs.
Okay.
And mutation testing is essentially where you evaluate how robust a DNN is by introducing small changes or mutations and then seeing how well it performs.
This is like a stress test.
Exactly. You're trying to find its breaking points.
Right.
And this method, DeepMAC, uses clustering techniques to make that process much faster. So instead of testing every single possible mutation, it strategically groups similar mutations together and then tests those clusters.
So it's like a shortcut that doesn't sacrifice the thoroughness of the testing.
Exactly.
Saves you time and computing power.
Yeah, and it really allows developers to assess and improve the robustness of their AI systems way more efficiently.
That's amazing.
Yeah.
We talked about this paper called The Journey Matters, Average Parameter Count Over Pre-Training, Unifies Sparse and Dense Scaling Laws a little bit earlier.
Yeah, we did.
Talking about sparse pre-training.
Right.
But it sounds like this research goes beyond just showing that this technique works.
It does.
What else did they uncover?
So it gets into this concept of scaling laws.
Scaling laws.
And these are basically these rules of thumb for how the performance of a language model scales with its size and the amount of data it's trained on.
Okay.
And this paper actually proposed a new scaling law that specifically takes into account the reduced number of parameters in sparse models.
So it's almost like it's giving you a blueprint for...
It is a blueprint.
For how to design and train these models more efficiently.
Exactly. And it doesn't matter what architecture you're using.
Oh, wow. So this has big implications.
Huge implications.
For the future of AI.
Absolutely.
That's exciting.
It is.
I feel like all of this really circles back to this idea of maximizing impact while minimizing resources.
Right, doing more with less.
Exactly. But it's not just about the technical aspects, is it?
No, you're right.
There's a bigger picture here.
There is.
When we talk about efficiency in AI.
It's also about responsible and ethical development.
Well, on that note,
yeah,
this has been an incredible journey.
It has.
To the world of AI research.
So many cool discoveries.
We've covered a lot of ground.
We have.
Denoising techniques.
Yeah.
Conceptual representations. The quest for greater efficiency.
The future is efficient.
It really is clear that this field is rapidly evolving.
Every single day.
And it's changing the world as we know it.
Absolutely.
We've only scratched the surface.
Just a glimpse.
But I think our goal with this deep dive was really to give you a sense of the latest advancements and trends in AI.
Yeah, hopefully we've given you some food for thought.
Definitely.
It's a field that's full of excitement, potential, but also challenges.
Absolutely.
And a lot of responsibility comes with it.
As AI continues to shape the world around us, I think it's crucial that we remember the importance of responsible development.
Could not agree more.
Ethical considerations.
Crucial.
And this ongoing pursuit of efficiency.
It all ties together.
Thank you so much for joining me on this deep dive.
The pleasure was all mine.
It's been an absolute pleasure exploring these ideas with you.
Likewise.
And to you, listener.
Yes.
Thank you for tuning in to the deep dive.
We appreciate you.
We hope you've enjoyed this journey into the world of AI.
Absolutely.
Be sure to check out the show notes.
Yes, good stuff in there.
For links to all of the research papers that we discussed.
Go deeper.
We'll catch you next time for another fascinating deep dive into the cutting edge of knowledge.